Hey guys, welcome back to my channel. My name is Micah. You guys are rocking with me on Micah's Intellectual Corner. On today's science reaction, we're going to be doing another Kurtz reaction, or another Kurtz video. This one is called The Largest Black Hole in the Universe. So, without any further ado, let's don't forget to check out my shorts series, and let's get right into it.
The largest things in the universe are black holes. In contrast to things like planets or stars, they have no physical size limit and can literally grow endlessly. Although in reality, specific things need to happen to create different kinds of black holes, from really tiny ones to the largest single things in the universe. So how do black holes grow? And how large is the largest of them all?
Well, I know the biggest one out of them, I'm pretty sure, is that ton 618 or 618. But, who knows if we've already discovered, anything else. But pretty sure that's the biggest one, if I'm not mistaken. Let's go ahead and get into it, though, guys.
This video will not discuss how black holes work or how they form, since we've looked at that in detail in our black hole and neutron star series. You can check them out afterwards. For now,
I will be doing a reaction to those two videos too eventually. I just have to make time for them, but eventually I will be doing those, just to let you guys know. Let's go ahead and get back into it though, guys.
Star series. You can check them out afterwards. For now, we're interested in finding the largest thing in the universe. Let's start really small. Primordial black holes. The smallest kind of black holes may or may not exist. If they do, they're probably the oldest objects in the universe, older even than atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy that any tiny pocket that was just slightly more dense than its neighbors.
Yeah, can you imagine how dense something, a universe the size of a microbe has to be? That has to be. I'm surprised it didn't start off as a black hole. If you think about it, that's how dense that was. But let's get back into it, though, guys.
More dense than its neighbors could produce a black hole. The smallest primordial black hole that could still be around would be 8 trillion kilograms or so, the mass of a big mountain. And yet they would be no bigger than a proton. A primordial black hole with the mass of Earth would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet. If they exist, they may even be the mysterious dark matter that holds galaxies together.
So it almost sounds like you can almost say that these primordial black holes anyway could be all around us right now. Like, I could be almost touching one as we speak, maybe. If that's... Alright guys, let's get ahead and get back into it though.
If they exist, they may even be the mysterious dark matter that holds galaxies together. Let's move on to the kinds of black holes that we know for sure are out there. Stellar black holes. To make a black hole, we need to compress enough matter so that it collapses into itself. After that, the more mass we throw at it, the larger it becomes. In today's universe, only the most violent cosmic events can create the necessary conditions, such as the merger of neutron stars or when the core of a very massive star collapses in a supernova. To have a unit to work with here, we'll use the mass of our Sun, about 2 million trillion kilograms. The smallest known black hole has 2.7 times the mass of the Sun, which works out as a sphere around 16 kilometers in diameter, large enough to cover Paris. Another lightweight black hole is the companion to the V723 Mon red giant star.
That kind of makes me think though, guys, how big of a star do you guys think ton 618 was? You know what I'm saying? It's a big ass freaking, excuse me, that's a really big, whatchamacallit. So how big of a whatchamacallit do you guys think that one was, Or like how big of a black hole do you guys think white Scooty is going to become, kind of crazy. Let's try and get back into it, guys.
Into the V723 Mon red giant star. This star is 24 times larger than our Sun, 30 million kilometers in diameter. And yet, it's thrown around by a tiny black hole just 17.2 kilometers wide. This tiny thing bullying the star is so much smaller that we can barely even show them in comparison.
I wonder if we get different pictures like this one, where the black hole is kind of sucking up the star from a close range from a star system like this. You think? I don't know. Let's go ahead and get back into it though, guys. It's very interesting though.
Barely even show them in comparison. One of the largest known stellar black holes is M33X7. It currently spends its time eating a 70 solar mass blue giant bit by bit. As all that stolen matter circles towards the black hole, like water going down a drain, friction heats it up to temperatures high enough to shine.
Okay, never mind. I guess that's where that one comes from. So very interesting. I wonder how a formation like that forms to where a black hole is that close to a star. That has to be in the solar system, you know? That's crazy. All right, let's go, guys.
Friction heats it up to temperatures high enough to shine 500,000 times brighter than our sun. And yet, X7 is only 15.65 solar masses and 92 kilometers wide, just big enough to cast a shadow on Corsica. To grow much larger, black holes have to either devour a lot of stars, or better, merge with one another. The instruments that make it possible to detect these mergers are very new, so we're currently discovering a lot of exciting things. Like two massive black holes that we detected in a galaxy 17 billion light-years away. As they spun around each other violently, they released more energy in the form of gravitational waves than the combined light from all the stars in the Milky Way in 4,400 years.
I mean, that amount of pure energy to make, reality pretty much into what is essentially a cartoon where things are literally bending like a bad meme, like a bad filter, you know what I'm saying? You know how strong that stuff has to be. I feel like even us, even though we can see it and we can witness it through instruments and stuff like that, you guys know I suck at words, but I feel like even though we can do that, we won't understand stuff like that for at least another 1,000 to 2,000 years at the very least. But yeah, let's go and get back into it then.
In 4,400 years. The new black hole they formed is about the size of Germany and is 142 solar masses. And here we hit a curious gap in scale. There are lots of black holes up to 150 solar masses, and then there's nothing for a long time. Until we suddenly hit black holes that are millions of times more massive. Which is a bit confusing because we had this idea that black holes are consistently growing and growing. But for the most massive black holes, this process is not fast enough to explain their existence today. The universe is simply not old enough for these supermassive black holes to have formed by eating stars and merging with each other. Something else must have happened. To explain how we got the largest black holes in the universe.
To me, all that essentially tells me is that, this stuff is probably wrong. You know what I'm saying? That theory might just be wrong, because if the theory is producing what seems like a paradox, and that means that there has to be another reason. Does that make sense? Where that has to be something else, like maybe we're wrong about the size of stars. Maybe we're wrong about something. Obviously, we have to be wrong about something because we can't just be perfect with everything that all of our theories, all of our notions that we have. So something has to give. But yeah. Let's go ahead and get back into it, guys. I can go on.
In how we got the largest black holes in the universe, we might need the largest stars that ever existed. Quasi stars. To get a sense of scale, we can compare them to the largest stars that exist today. Our sun is like a grain of sand next to them. We don't know if quasi stars actually existed, but they're an interesting concept when it comes to supercharging black hole development. The idea is that the matter in the early universe was so dense that quasi-stars could grow to thousands of times the mass of our sun. The cores of these stars might have been crushed by their own weight so much to actually collapse into black holes while the star was still forming. In contrast to stars today that would destroy themselves in the process, inside quasi-stars, a deadly balance could emerge. Gravity pressed the supermassive star together, feeding the black hole and heating the material falling in to such a degree that the radiation pressure kept the star stable.
Kind of sounds like a snake that's just continuously eating itself. You know what I'm saying? You guys ever seen those pictures with that? I probably put one up. But yeah, it just sounds kind of like that, where it's just a snake kind of just eating itself until eventually it can't eat no more. There's nothing left, and it just, I guess, turns into a supermassive black hole. Alright guys, let's go and get back into it though.
The material falling in to such a degree that the radiation pressure kept the star stable. And so these quickly growing black holes might have been able to consume the quasi star for millions of years and grow far bigger than any modern stellar black hole. Black holes several thousand times the mass of the Sun and wider than the entire Earth. These black holes might have become the seeds for supermassive black holes. So now we arrive at the kings of our universe, the largest single bodies in existence.
Real quick too, I just want to say, if you guys see this, like how we, the picture of a black hole, how a lot of artists rendition it, how like we're seeing in this video. Just a quick, fun fact, that's actually how a black hole looks mathematically, if that makes sense. If you put, I think it was Interstellar who went to an actual physicist or whatever type of scientist that deals with that. You have to forgive me, but the scientist actually gave them the mathematical number for a black hole. What essentially a black hole is mathematically. They put it into a computer, and the computer itself resonated what this picture is, and what it essentially is the gravitational of it is so massive that what we're seeing of a 2D black hole is actually bending actual time and space itself, and what we're seeing is a mirroring image of that. The back part is just a mirror image of the space. I think of either it from above or something like that. That's how massive the gravitation is with these black holes. But just a quick fun fact. I think Interstellar actually got a reward for that though. But yeah, let's go ahead and get back into it though, guys.
So now we arrive at the kings of our universe, the largest single bodies in existence. The centers of most galaxies contain a supermassive black hole, and they are monstrous. In the Milky Way, we have Sagittarius A star, a supermassive black hole with about 4 million solar masses that is calm and collected and just does its thing. We know it sits there because we can see a number of stars being thrown around by a seemingly empty spot. And despite its incredible mass, its radius is still only 17 times our Sun. Smaller than most giant stars.
That's kind of creepy to think that we can, not creepy, but eerie, I guess is a good word for it, to just think that we can look out into the sky and there's an actual black hole just right there in the darkness, and you can't see it because it's a black hole, but it's right there, and it's actually making stars move. Like, that's so eerie to me. I don't know why, but it also makes me love this stuff. But let's go ahead and get back into it though, guys.
Smaller than most giant stars, but millions of times more massive. Because supermassive black holes are so massive and located at the center of galaxies, many people imagine them as being a bit like the Sun in the solar system. An anchor that glues everything else together and forces it into an orbit. But this is a misconception. While the Sun makes up 99.86% of all the mass in the solar system, supermassive black holes usually only have 0.001% of the mass of their galaxy. The billions of stars in galaxies are not gravitationally bound.
I think that we also have to remember that, unlike, the solar system or unlike that, the inside of a black hole by the galactic core, unlike a solar system, like where we are, is nowhere that you want to be, because it's literally so hectic there that even if there's life there, I feel like it's just destroying and rebuilding itself in a constant cycle. It's really messed up to think about, but alright, let's go ahead and get back into it though, guys.
A galaxy. The billions of stars in galaxies are not gravitationally bound to them. Instead, it's the gravitational effect of dark matter which holds them together. Many supermassive black holes aren't gentle giants, especially when they're feeding on the clouds of mass in their galaxy. The one at the center of the BL Lacerti galaxy is devouring so much material that it produces jets of plasma accelerated to nearly the speed of light. If Earth were orbiting this huge body, it would seem 115 times larger than our Sun in the sky, and we'd be burnt to a crisp in seconds by its glowing hot accretion disk. At this point, black holes...
I feel like at this point, we're only talking about galactic cores at this point. Like, ugh, it's kind of making my stomach feel weird thinking about this type of stuff, you know what I'm saying? Let's go and get back into it though.
At this point, black holes become so large that stars seem ridiculously tiny compared to them. The galaxy Cygnus A has a supermassive black hole with 2.5 billion solar masses and 14.7 billion kilometers wide, which would mean that if it took the place of our Sun, it would swallow all the planets and stretch halfway to the edge of our solar system. It's devouring so much mass and material that it churns its disk into a kind of magnetic funnel, spewing gas out, making tremendous radio lobes towering over the galaxy 500,000 light.
I don't think we can fully appreciate that picture and how truly massive it is, because I feel like just get from the edge of one of those magnetic bursts, it would take like billions of years just to get from the edge just to the center. Not from edge to edge, just from the edge to the center. That's how massive that is. Like, I'm talking years. Like, it's just incredible.
Making tremendous radio lobes towering over the galaxy 500,000 light years in diameter. That's 2.5 Milky Ways wide. Another pretty large supermassive black hole sits in the galaxy Messier 87. It has 6.5 billion solar masses and was the first black hole we got an actual photo of, or rather, of the glowing gas around the edge of a menacing shadow. This sphere of darkness is so large that it covers our entire solar system. And yet, there is a scale even above these kinds of objects.
I feel like at this point, we're talking like comic book type of stuff, you know what I'm saying? Like, but it's real life. This exists in our universe, right above our heads. As we speak, it is turning. That is insane.
There is a scale even above these kinds of objects. Ultramassive black holes. Now we reach the most massive black holes, perhaps the largest single bodies that will ever exist. These black holes have eaten so much that they've grown to tens of billions of solar masses, their gravity the engine for a quasar, an accretion disk shining brighter than thousands of galaxies full of stars. So massive that they deserve a title of their own: ultramassive black holes. The ultramassive black hole at the center of galaxy OJ287 is 18 billion solar masses. It's so big that it has a supermassive black hole nearly 40 times larger than
That's really hard to take in, you know what I'm saying? Like, it's so massive. It has almost a galaxy size, I don't know. You just can't appreciate this type of stuff, you know what I'm saying, without actually seeing it in person. I feel like, these type of pictures just don't do it justice, but is ridiculous because this is not even the biggest one, you know what I'm saying? This is ridiculous to think about. Right, but let's go ahead and get back into it though.
That it has a supermassive black hole nearly 40 times larger than Sagittarius A star orbiting it. This thing defies imagination and is really hard to compare to anything. It can comfortably fit 3 solar systems side by side inside of it. Let's end this insane competition and get to the King of Kings. Ton 618, a black hole that we can observe consuming galaxies worth of matter, is shining with the brightness of 100 trillion stars, visible from 18 billion light years away. It has an incredible 66 billion solar masses. A black hole so large that it would take light a week to reach the singularity after crossing the event horizon. About 11 solar systems could sit inside of it, side by side.
Can you imagine what this damn thing is going to look like at, say, the edge of at the end of the black hole era, like in, say, our Melody Sheet video? Can you imagine that? Like, that is ridiculous. ridiculous. Could you imagine how big that thing's going to get in a quintillion years, Googleplex year? You know what I'm saying?
Systems could sit inside of it side by side. It may very well be the largest single body in the universe, but in reality, it's probably even larger. Since Ton 618 is so far away, we only see what it looked like 10 billion years ago. In any case, black holes are scary and mysterious and gigantic. They'll be here after everything else dies and growing larger and larger. Okay, now let's do the trip again. From the smallest...
Before we do this, I can say one thing. Can you imagine? I already know. There has to be one even more massive than that one, and I feel like it's probably either lurking somewhere in the dark reaches of our own universe, observable universe, or it's like right on the other side of that event horizon or whatever, not event horizon, the cosmic horizon. In probably like another million years, we're about to see one. You know what I'm saying? One of the most mind-numbing things we've ever imagined. You know what I'm saying? That's crazy. All right, let's go ahead and try to get this video out, guys.
Okay, now let's do the trip again. From the smallest possible black hole all the way up to the largest.
What we need to do is get a picture of that freaking Ton 618 like we got a picture of the other one. Can you imagine that?
Let's try something new today. We can call it Behind the Line.
Alright guys, we'll go ahead and stop it right there. So yeah, another great Kurt's video. Should have hit this one up a little bit sooner, but we're deep into our other series. So if you guys love the content, please check out my other series. A lot of different history series, and of course a lot of different other science series. Like I said, I do Melody Sheet Kurtz. We're going to dive into some other stuff here. Our very next video, I'm doing a recommendation video. It's something Arthur. I have to go back to it, but it's definitely a recommendation video, and I appreciate it. With that being said, though, guys, please don't forget to check out my short series Today in History. See you guys when I see you. I'm out. Peace.